So we're 46 attendees. If it's not going up in a few seconds, we'll start.
Hello, YouTube.
Hello,
Okay.
world.
So let's start it for today's meetup. Or we wait one more minute.
I think we can get going.
Yeah. 52.
Yeah.
It's still climbing. Like, I guess attendees are late today.
I think we're a good number now, so that's a good point to start 50.
Okay, plus 50. Let's start that. So hello everybody, and thanks for joining us today. I guess everything is done here. Let's go to the agenda. So today's agenda, we have a little bit of housekeeping. We have the KubeCon wrap up. So we're going to present you a few of the talks that our organizers like the most. And then we have a great talk about Distroless, so how to secure Docker images using Distroless. And this talk is from Melissa McKay from Jfrog. And we have huge prizes today, thanks to Jfrog. We'll get to that later on. So our host today, myself, Julia, and Archie, as always, Anthony, will also talk about his picks of KubeCon talks. The CNCF and Kubernetes organizers, it's a big family and it's growing almost every time. So thanks everybody for being part of it. So we have now 2 slides for the organizers. So thank you all. We have sponsors, and so thanks again to Elastic and Jfrog for helping us organizing all that and providing swag and whatever we need. That's a great support. You can become a sponsor. We have a QR code here, and you can find that in the slides that we're going to share later on. So if your company wants to be part of it, you're welcome, and you will have like time slots for speaking if you have like great things to share with us. So let's do that. So let's go. We already talked about that. So CNCF update and the Melissa's talk. I want to mention that we also have a survey at the end, and this is helping us to better organize and present things for you. So please fill the survey at the end. So as always, there's different ways to reach to us: Slack, LinkedIn, and Twitter. Please come to the Slack channel if you have some questions. There's great people there bringing a lot of information and news about Kubernetes and CNCF projects. So please join. We have CFPs. So if you want to participate, if you have a talk to submit to us, the links are here. Please come to the Slack channel or use these links to submit your talks. CNCF announcement. So there was KubeCon not actually last month, this month, 2 weeks ago. We have some stats about this KubeCon. It was very special. It was the first in the last 2 years. It was a great event. So a lot of attendees, actually virtual, mostly virtual, sadly. Great stats. Canada represents a lot in this KubeCon because it's the 3rd overall country of participants. We're very proud of that. So for in-person, 3,500 and something, that's great. That's great for a first one in a COVID time. I can tell you that everything was secure, a lot of checks, everybody was wearing masks inside. It doesn't feel like COVID at all, except for like having face masks. And I'm sure like Archie or Julia will be able to comment on that. But I had a great impression. And almost 20,000 attendees online. What I can see, it's a lot of men, and still we have very few women to these kind of technical events. So join us every time. And once again here, even virtual, Canada is the third country of attendees. So that's great. We're a great crowd. Okay. Few pictures. So, KubeCon, it's keynotes, sessions, and parties actually, and meeting people. So that's also a great part of the KubeCon. And we have a big picture in the middle, all Canadian folks. There was a lot more than that, but
You were hiding.
So the picks. So I only have one because at the beginning we said everybody's going to pick one, so I picked one. It's about Salesforce explaining how they build PaaS, so platform as a service, using CRDs. So it's the new OAM model where you define your applications in operators, and you have everything inside the cluster taking care of the CI/CD and bringing up everything that is needed. So the users can just describe the application and everything is taken care of by automation in the cluster. That was a very great talk, very inspiring. So that's my take. Anthony?
Yes, sure. Hello, everybody. Thanks, Sebastian. So yeah, I was a virtual attendee. I was part of 20,000 joining online, and yeah, well, first of all, it was a pretty decent experience actually. Whether it was, so there were people presenting live, and they were being, of course, live streamed. So there were also a lot of recorded talks. I guess it was 50-50 to my opinion, but I don't have the official stats. Anyways, it was a very pleasant experience following from my living room. So, of course, I still, I have picked three themes that I really liked and that were super well represented at KubeCon. First of all, the developer experience. The developer experience was really put in focus this year. Many people, many speakers were talking about telepresence, this dark magic from Ambassador Labs that allows you to actually have local processes on your machine being exposed to your remote cluster. So a very nice tool that is gaining actually a 2.0 release. I think it was this year. So it's a really nice tool to check out. I highly recommend it to you. New to me was Bridge to Kubernetes, something very similar from Microsoft that is well integrated with VS Code. And same thing, it allows also to send some remote traffic to your local process. A nice tool that I didn't know about as well was Dapper. Dapper from Microsoft as well. So if you're familiar with Istio architecture, it's kind of the same thing, but focused for developers this time, meaning that you will be able with Dapper to inject some sidecar containers that will do things such as resolving network, mounting volumes, and so on and so forth. So all those, those aspects of configuration that can be hard to do with Kubernetes, then Dapper is going to actually remove all the configuration from your application and put it in the centralized Dapper place. So that definitely seems to be a good tool to check out. Porter also was new. It's kind of a packaging for Kubernetes. I'm not sure where that's going to go, but the idea was, to be able to safely package some deployments to Kubernetes using this tool. So that's it for my developer experience. But as you can see below on the slide, apparently Archie also picked up some interesting tools. So more to come. Then on the observability side, open telemetry everywhere. This is the merge of OpenCensus, OpenMetrics, and OpenTracing. This is the way to go. OpenTelemetry is GA for traces. This is your go-to tool if you want to do some traces instrumentation for sure. They even have metric support now, although it's only in beta, and also they envision bringing logs support as well. Interestingly enough, the open source Jaeger seems to be evolving into a full APM tool. So they were only about traces before, but now they really want to encompass more observability pillars. Finally, GitOps GitOps everywhere thanks to Flux and most certainly AlgoCD. AlgoCD is now so mature that there are a lot of integration that appeared with it, such as AlgoCD application set, where you can actually bundle several applications into AlgoCD easily. I've also seen some interesting plugins to integrate with Vault and other secret managers. So yeah, AlgoCD is really big now and super official. That's it for my takes. I will also paste some links in this chat as well as on Slack with some blog posts about what happened at KubeCon.
Thanks, Anthony. I actually want to add a few more words about AlgoCD that we had a last meetup around AlgoCD. And at KubeCon, I saw two new companies that are packaging AlgoCD and they're hiring people. So if you're interested to work in AlgoCD space, there are companies actually hiring now, and you can join them in the different positions, starting from software developer to developer, DevRels like Melissa, for example. So check it out. And if you're looking for that, let me know. I'll be happy to connect you. But honestly, for myself, I was just happy to be in person at KubeCon LA and to see old friends, meet the community, go to the rooftop parties, and have lots of swag. So I had like 2 bags of swag that I brought with me from Los Angeles. At KubeCon, I was a track host, so I was representing different speakers before they present, and I was very lucky to represent Katrina Verey from Canada. She's working today at Apple, and she's a 6 CLI lead, so she was presenting at around Customize. But most of the time, I usually spend at the booth, so I go check my old friends, like a company like Jfrog, or see the new companies who are up there, and just trying to understand, where the industry is going and what's happening, and get some swag. And obviously, for me, the main goal is to find new talks and new sponsors for meetups. So I had to agree with Anthony on that. The developer experience with Kubernetes is becoming one of the major focus in this Kubernetes space. Without going to the talks, I was at the booth. I checked few interesting companies that I haven't seen before that appeared post-COVID. So one company is called Garden, and they have a project Garden that lets developers not only have a developer Kubernetes loop locally, but also developers can run part of the CI locally. So that kind of helps developers to have end-to-end loop to understand their software much better. Obviously, project Tilt from CNCF, which is still in sandbox, but is getting a lot of tractions. If you know Scaffold project from Google, this is very, very similar to that. And I've met the DevRel, so they're probably going to come to present at our meetup shortly. Another project very cool is DevSpace. It's coming from a company called Loft. So they allow you to easily deploy Kubernetes application using like a Docker Compose style approach. And then finally, a very funny name in French, Project Kui. So let's build a framework for enhancing CLIs with graphics. I just really like the name, so I brought it up. The second trend that I've seen at the event, and I think most of you agree as well, is like around Kubernetes security and eBPF. So I really like Project Loft. It provides tools to solve multi-tenancy problems with Kubernetes, which I think everyone is agreed that is very difficult. So they have a project called vCluster that lets you create virtual cluster on the same Kubernetes cluster and kind of provides isolation for developers to run their workloads. And then a very interesting project called GS Policy. So if you're familiar with OPA and Caverno, this is very similar tool, but you kind of creating the policies in JavaScript. So if your company have lots of JavaScript developers, they're gonna love it. But I think like one of the coolest project that I've seen overall, it was a project called Pixie, which is sandbox project in CNCF that is powered by eBPF and provides you observability and debugging for developers without any instrumentation. So it just magically starts, and then you can see all the your services connections, your debugging, your metrics. So it's pretty cool to check out. You can install it, try it out. I highly recommend. It has a nice UI as well. So that's I think one of the coolest things that I've seen. And finally, I think one area that had huge traction, including the keynotes, was security supply chain. And I think it's thanks to my friends in Russia that recently hacked SolarWinds. It's kind of becoming a key focus for us. So even in a Kubernetes community, we want that Kubernetes development is secure, and we want that Kubernetes application is securely deployed, right? So the first initiative that you see there, it's called SigStore. It's an initiative started by Red Hat and Google that provides you a new standard for signing and verifying and protecting your software. And it's funny enough, there's few Google employers that left the Google and started a new startup called ChainGuard. So check it out. They are hiring right now. So if you want to work in the security supply chain, this is a very cool company to check out. And another thing that has been talked at Keynote, something called SBOM, Software Bill of Materials. This is essentially, we're trying to make sure that even Kubernetes pipeline has, all the software that is dependencies that are all secure. So that was my kind of very short recap, but honestly, I haven't gone to many talks. I'm still looking forward to see the recordings that are available on the platform, or they're going to be available on YouTube shortly, maybe in a couple of weeks. Sebastian, back to you. Or Julia.
Yeah, back to Julia.
Yay. Hi, everybody. I just wanted to take a moment to, I guess, talk about my experience. So my favorite talk was my talk because it's about a topic that is very important to me and near and dear to my heart. It was about my burnout and depression and mental health journey and experience a couple of years ago. So I felt very fortunate and I was very honored to be able to do this talk in person. I've done it a couple of times online, and it was a much more nerve-wracking experience to do it in person, but it was very well attended, and our Canadian community was so supportive and put my little burnout ribbons on their tags, and I was really, really happy to have you all there, and all of you who sent me messages after and who got in touch with me. It really, I can't express how much it means to me. So thank you so much for, supporting not just my talk and the topic, but also, I guess, my journey from, being a non-technical contributor to being able to do this. It was really special for me. So enough about me. My favorite talk at KubeCon was one of the keynotes, actually, because it was about people and I guess also the developer experience, but it was a keynote by Robert Duffy, and he talks a lot about how they work together and how meaningful that is. So if you do have a chance to check it out, I highly recommend. It was actually in a bit of a series with the other co-chairs of the conference, so Constance and Jasmine, and really kind of talking about the human element, which obviously, as you can see, is my jam. So I really appreciated that this is starting to become more of a topic and more of a focus for these conferences. And as Archie mentioned, there will be talks available. It's actually this Friday as of the 29th. So all the talks from KubeCon will be available on the CNCF YouTube channel as of this Friday, so you can check those all out. And if you just want to switch, so in vein of all this, a wonderful new friend who's actually here attending, Thomas, reached out to me and asked if we would create a peer support group. So that's what we're doing. So if anybody wants to talk about burnout or just how they're doing and any struggles they might be having, or just wants to connect with people in a different way, please join the CNCF Slack workspace. So the link is here, slack.cncf.io, and there's a channel in there called Burnout, and we are going to be doing weekly huddles in Slack in that space, in that workspace. So right now they're Thursdays at 12 p.m. Eastern. So if you'd like to join us, we're going to be doing them weekly for the first little bit, and we'll see how it goes and how people like it. But I just wanted to give Thomas a shout out and also support or promote our little initiative here. So hope to see you there. I'll pass it back to you, Sebastian. Thank you, everybody.
Yeah, thank you. I want to add that I was at Julia's talk. It was awesome. It was crowded. And actually, it was a lot of men. Usually, like men, we're strong. We don't talk about that. And that was very great to see how many they were. And I want to relate that to of course, Carey Price experience. Like we as Canadians have to work around burnouts and be honest about it and share our thoughts. And so that was a great experience. And thank you again, Julia, for bringing that to everybody and supporting this.
Thanks.
Next events, actually. So in the coming month, we have in December, actually, China KubeCon. And then next year, you have the dates, Valencia, Spain, and then next year for us, North America in Detroit. So very close to Canada for once. And then Archie, it's your turn.
All right. I just want to mention before we're going to start with the presenter, we're going to have at the end of our meetup a post-event survey that will have a prize draw sponsored by Jfrog. So we'll have Kubernetes mask. We have also titanium key that helps you to protect your secure supply chain from phishing. And most importantly, the best prize is a Raspberry Pi 4 desktop kit. So please stick with us until the end. Don't drop and get a chance to win the amazing prizes from a nice Jfrog company.
and don't forget to fill the survey, because you have to fill the survey to be a participant.
Yeah, exactly. Yeah, just a survey. And then finally, I want to invite Melissa McKay from Jfrog. So I was looking for her all the time at KubeCon, but I couldn't find her. And I just find the fun fact about her, she never visited Canada. So we'll try to make sure we're going to fix that problem and she will be able to come us. And the topic of today's presentation is actually very close to my heart. I have a lot of users and people asking me how to run those, Docker images securely on Kubernetes cluster. So, and I heard about the project that I think started by Google, Jfrog, and a few others around Distroless Docker images. So when I saw that Melissa is presenting around this topic, I was very excited, and we invited her to present at our meetup. Melissa, welcome. I think you're muted, but yeah, I can.
Thank you. Yeah, thanks for the introduction and for the invite to Canada. I'll definitely be up there as soon as I can. One thing I wanted to say about going to KubeCon was, I kind of think of myself as more of an introvert. I thought I was just fine not being around people, but I tell you what, I mean, going to that conference fed my soul in ways I didn't expect. I didn't even know I was that hungry for in-person events again. So looking forward to the next one, hoping things improve across the country and we'll be able to continue doing that. All right, let's go ahead and get started. Okay, so this is a talk that I've somewhat modified to include a discussion about Distroless. It's a talk I've given a few times and have had a lot of interest in. And it goes back to the basics, all the way back to the developer when you are actually building your images and when you're putting your application together. So this falls right in line with supply chain security. These issues have been around a long time. And I'm actually surprised that this hasn't caused us more problems. But obviously, we're hearing more and more in the media about security problems with certain applications and certain packages that cause some, a lot of media attention and a lot of problems for some companies. I feel bad that SolarWinds is now the example that we all give for how this kind of thing can happen. So just to set some expectations up front, there is a lot of information about Docker in this talk, but this isn't really a tutorial on Docker or a deep dive in Docker commands or anything like that. When I put this talk together, I wanted to do something a little bit different. I did a lot of background research to focus more on how we got here and to get some answers to some of the big why questions around containers in general. And my hope is you'll come away with a better understanding of the history behind containers, how they actually work on your system, and some of what is really going on under the covers. Obviously, this is a few steps back from actually deploying your containers using Kubernetes. This is all the way back to building the initial images to begin with that your containers are based on. So we need to shift that security left all the way back to when they're first built. And then I'll lead into a discussion about distroless containers and what that means. All right, so let's go. We do have an extra chance for a t-shirt and a liquid software book provided by Jfrog. These are available at the link that you see here on the screen. Actually, let me try posting that link so that it's a little bit easier for you. Okay, I posted that in the chat. My slides will be posted there. The video will be there eventually, but obviously this meetup group will probably post stuff as well. The first 15 people that sign up for this raffle will get a t-shirt and a book. So please go there. You can also rate my talk there. All right. I was already introduced. I am Melissa McKay. I am a developer advocate with Jfrog. Real quickly, my background is actually as a developer. I've been a developer for 20 years, all the way from an intern to principal engineer. But about a year and a half ago, I decided that I really, really enjoyed public speaking. I enjoyed teaching, and it was getting to be a little bit too much to do that on top of my full-time job as an engineer. So I was looking around for opportunities to actually get paid to do this kind of thing, and Jfrog came about, and I was pretty thrilled. It's my dream job in a way, working with some people I've known for years and years, and I'm really enjoying how the developer relations program has grown and started with Jfrog. I am a Java champion. Primarily my background is Java server-side coding, and I'm also a Docker captain. You can reach me on Twitter, on LinkedIn. I've got my contact information here. All right, so like I said, we're going to learn about history, because sometimes we just need to, remind ourselves how we got here to begin with. We'll look a little bit look at containers in real life, how they look on your system, specifically my MacBook, because that's what I used. And then container gachas, things that I experienced when I first started using containers, and that will lead right into distroless images and what those are all about. All right, I have several talks now where I have a theme, and my favorite theme right now for Docker images and containers is bananas. I absolutely refuse to use shipping container pictures in any more talks or anything. I'm tired of seeing those. So we get bananas. And I'm sorry, somebody says Sebastian, you hate bananas. That's too bad. Here they are. You're going to get a lot of bananas in this talk. All right. So in the beginning, when all of this started, this whole idea of using containers, there were obvious limits on time and resources that created bottlenecks and inefficiency with just the physical hardware even. And just being able to share a workstation was not enough. There needed to be a way to share without getting in each other's way or having one person inadvertently cause an entire system to crash for everyone. Fast forward to the future, now we're looking at huge infrastructures where we do, blue-green deployments, and we're really working hard on not destroying an application for all users when we make little changes and want to update our stuff. But back then, way back then, I'm aging myself a little bit, we needed better strategies in sharing compute resources. And that actually started this path of innovation that we see massive benefits from today. There's some key points that brought us to the state we are in. And I'm going to begin our container history lesson with Chroot. That was born in 1979 during the development of the 7th edition of Unix and was added to the Berkeley software distribution in 1982. Being able to change that apparent root directory for a process and its children, which Chroot allowed you to do, resulted in a bit of isolation in order to provide an environment for testing a distribution, for example. In fact, that's how it was introduced, was as a test utility, which grew into something more. So Chroot was a great idea, solved some specific problems, but more was needed. And the jail command was introduced by FreeBSD in 2000. Jail is more sophisticated than Chroot in that its additional features help further isolate file systems. users and networks, and has the ability to assign an IP address to each jail. In 2004, Solaris Zones brought us ahead even further, giving an application full user, process, and file system space and access to system hardware. Solaris Zones also introduced that idea of being able to snapshot a file system, or made it popular anyway. Obviously, this is something super important when you're talking about VMs, snapshotting a VM, and also of creating an image. In 2006, Google jumped in with their process containers. Those were later named C groups, which might be more of a familiar term for you. That centered around isolating and limiting the resource usage of a single process. And moving right along, in 2008, C groups were merged into the Linux kernel, and along with Linux namespaces, that led to IBM's development of Linux containers. So just right away, I just noticed containers are not a new thing. They've been around a while. All right, 2013 was a big year. That's when Docker came on the scene. They brought their ability to package containers and move them from one environment to another. And that same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own subcontainers. And from here, we see the use of containers and Docker specifically explode. In 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. That was something interesting when I first started using containers, realizing that Docker was written in Go. And I'm almost done with this history lesson, but I'm going to skip over some details, but there is an important date that I want to get to that happened in June 2015, and that was the Open Container Project Initiative. This event is really important to know about because it'll give you insight into some of the activity and innovation or motivations behind shifts in the market. And this organization was established under the Linux Foundation. It includes members from many major stakeholders, including Docker, with the goal of creating open standards for container runtimes and image specs. All right, well, all of this is happening in the container world. There's a couple of other dates I'm just going to throw out there because I'm a Java person and I'm selfish. So Java 7 was released in 2011. Work was started on Java 8, which was released in March of 2014. Keep that in mind because when you start containerizing Java applications, this little bit of history is important to know. It'll come up again later. Just note that containers and the whole environment and Docker was in the middle of making stuff work for everyone, and Java was still continuing on its own way as well. All right, that's it for our history lesson. Thanks for paying attention. I know that was a lot on one slide, but I think it's good to have that background just to understand how we got here. So what exactly is a container? I always find it interesting when I discuss these with people, getting the terms correct about, containers versus images. I'm sure all of you in this audience know the difference, but it's sometimes frustrating to me to hear them being, used in place of each other. An image is actually, the blueprint that a container uses to run on your system. For those that don't know that, that's the main difference. So I want to just show you what a real life container looks like when it's actually run on your system. And I'll show you how it's actually stored, what's happening under the covers, and you'll discover that it's really not all that magical. All right, so my first experience with containers was on a developer with a tight deadline. Of course, I think that's pretty typical, and that's probably a good description of most projects. The best course of action for me was just to jump in and start getting something up and running on my local machine. And I learned best by doing, and the Docker documentation is actually really good. So, that really helped me a lot. If you find yourself in a similar position, definitely go to their Get Started docs. I've linked those here. And going through that guide will get you comfortable with the Docker commands that you need and all of that. But the first thing to note is a Docker image is really just a tarball of a complete file system. And when an image is unpacked, it's just thrown into its own directory, which becomes its root file system. The second is that processes that are involved in running the containers are just regular Linux processes. On top of that, there are just a few Linux features that are used together in a way to achieve that isolation that we want from containers. And here you can see I had some running on my system. Namespaces are an important ingredient. This is what's used to provide the virtual separation between containers and how the processes inside a container don't interfere with the host or processes inside another container. So these are just some of the namespaces that were set up for a Postgres container that I had running on my box. The C groups functionality is essential to constraining how much a container can use things like CPU, memory, network bandwidth, etc. And I can set these constraints by including options on the Docker run command when launching an image on my local machine as a developer. And here you can see I've constrained the memory usage limit on one of my containers. Now, a lot of orchestration will handle this for you. There are settings, in your YAML files that you can set to set these constraints. All right, I'm going to quickly gloss over just some file system details that are interesting, where containers and images are actually stored on your file system. First off, after you've installed Docker, running the command docker info will spit out a bunch of information about your installation, including the Docker root directory. And this is where most everything you're going to care about regarding your Docker images and containers will be stored. And if you're on a Mac, note that your containers are actually running in a tiny VM. So you're going to need to use screen or something like that to get in there and get the Docker root directory to look around. If you're not familiar with the screen command, definitely Google that, get familiar with it first, because it's pretty easy to mess up your text display if you don't enter an exit screen in the right way. All right, this slide shows how you get information about the images that are stored on your system. I listed my available images using the Docker images command, and I have several installed, but only the first are a couple displayed here. Using the Docker inspect command, I can inspect any image I like using its image ID, which spits out a ton of information. But I want to highlight here the graph driver section, which contains the paths to the directories where all of the layers that belong to this image live. Docker images are composed of layers, which represent instructions in the Docker file that was used to build the image originally. These layers translate into directories, and these layers can be shared across images in order to save space. Pretty clever. The lower dir, merge dir, and upper dir sections are especially important. The lower dir directory contains all of the directories or layers that were used to build the original image. This is going to be important when we talk about distroless images later. These are read-only. The upper dir directory contains all of the content that has been modified while the container is running. If modifications are needed for a read-only layer in lower dir, then that layer is copied into the upper dir where it can be written to. This is called a copy on write operation. It's important to remember the data in the upper dir is ephemeral data. It will only live as long as the container lives. In fact, if you have data that you intend to keep, you should utilize the volume features and mount a location that will stick around after the container dies. This is how most containers running a database are run, for example, or that rely on a database. Lastly, the merge dir is kind of like a virtual directory that combines everything from lower dir and upper dir. And the way the union file system works is that any edited layers that were copied into upper dir will overlay layers in the lower dir. So if you were to exec into a container, for example, you would see the result of that merge. All right, this is another slide showing a couple of containers currently running on my system. One of them is my local Jfrog container registry installation that includes a container for Artifactory and a container for a Postgres database. The other simple is just a test container that I was playing around with. Note that the container IDs of the running containers match up with the container subdirectory names. And something to remember here is if you stop a container, that corresponding directory doesn't automatically go away until the container is actually removed with the Docker remove command. So if you have stopped containers lying around that never get cleaned up, you might see your available space on the system start to dwindle. There is a Docker system prune command you can run every now and then to help clean things up, or you can launch a container with the flag to indicate that it should be removed when it's finished running. Now, obviously, this is for development, perhaps test environments. Your orchestration like Kubernetes can handle this for you as well. All right, container gotchas. Okay, this is my favorite part of this presentation. There were several things that I ran into when I first started using containers. They are very easy to set up and get running, but there are a lot of ways to put your images together that are going to lead to some consequences that you're going to end up cleaning up later, I guarantee. So the tool sets around building and running images and containers have made things so easy. It's also easy to shoot yourself in the foot, and it's deceptively simple. I'm just going to go over a few of the common gotchas, including some JVM specific gotchas that I ran into almost immediately. Another thing I want to note here is I do say a lot of Docker, and that's my focus right now, but this also applies to OCI images as well. OCI is, the standards that Docker follows, but just note that when I say images, I don't only mean Docker images, or even the tool set. There are a lot of other tools now to build and deploy your images as well. All right, so the first is running a containerized application as the root user. I think this is pretty common, well known, but I'll be honest, when I was initially getting stuff up and running, I was so excited about it even working that it was a while before I took it seriously. And now that you know that processes that are running inside a container are just like any other process on the system, albeit just a few constraints, it's scary now to run as root inside a container. Doing that opens up the possibility of a process escaping those intended confines of the container and gaining access to host resources. Reduce your attack surface of your container by following the principle of least privilege. And although containers are designed not to affect other running containers, if someone were to gain access to your container and immediately have root privileges, they can wreak havoc not only on your application, but on the host and everything else running on the host. So how do we mitigate this problem? The best thing to do is create a user. You can use the user command inside of a Docker file when the container is built in order to run processes as that user. And there's a way to specify a user when the Docker run command is used, but that obviously leaves open the possibility of forgetting to do that. So it's nice if your production image is just set up by default not to run as root. Also, pay attention to official images that you pull from Docker Hub. Whether or not they run as root or if they leave that up to you to fix. All right, even though Docker provides you with the ability to set resource limits on your container, it doesn't automatically do that for you. In fact, the default settings are a free-for-all. So make sure you understand the resource needs of your application. Too little, your container will die from starvation. Too much, and your container could smother others on the system. So just running containers does not give you a license to be lazy and not understand the resource needs of your application. The resource usage of your containers is something you're going to want to monitor over time as well and adjust as needed. It's a good way to determine if something's going wrong or if load on your system has changed for some other reason. You could also use that monitoring information to determine if your application needs to be split up further with certain actions scaled differently. The most obvious is front end and back end activities. All right, never updating. So this is a pretty big security issue, and now we're getting into the guts of this. It's easy to get complacent and not pay attention to what is actually getting pulled in when you build images. So not only do you need to be aware of outdated versions of libraries and packages that you specify in your own Docker file, but you need to pay attention to that base image and where it's coming from. Not updating those packages and libraries inside your container can lead to some pretty embarrassing results, especially when there are tools available now to alert you when security issues have been discovered. I'll actually show you what that looks like in a moment. And even ensuring that you're running containers with a non-privileged user has risk when there are known vulnerabilities that exist within your container, or even on the kernel of the host for that matter. From time to time, these exploits are found that enable attackers to potentially escape a container. So keep up with those security updates. I know I've been on teams where that has not been a priority primarily because of the fear of breaking a product or a service that's already running. But that's a symptom of a different problem that really does need to be solved. It's much worse to leak private data or potentially be the start of a domino effect that can bring an entire system down. So definitely get those updates. All right, this is very Java specific. Again, I am a Java programmer and I'm selfish. So I mentioned earlier about the dates when Java 7 and Java 8 came out. Obviously, we're all the way to Java 17 now, and 11 is out. But there are still, for various reasons, a lot of enterprise applications that are still running Java 8. So considering that timeline of Docker and Java releases, Java 7 and early versions of Java 8 are not fully container aware. This means that your Java application won't necessarily obey memory and CPU constraints that you put on your container, and you may end up with some surprise out of memory killer activity. The reason for that is the mechanisms that JVM uses in these older versions to retrieve the resources that are available come from the actual host machine and not from the C group limits that you would expect. So obviously this has been fixed now. There were some improvements around container awareness that were introduced in Java 8, update 131. And there were further improvements in later versions. But to really get all of the benefits of container awareness, you really should get to Java 11. And that's, the latest release that is container aware. All right, image bloat. So it was a long time before I realized I needed to start using a Docker ignore file. This file is much like git ignore. When you build your images, you are sending a context, the entire context to the Docker daemon, and it uses that context to build your image. And sometimes if you're not careful and you do a wildcard copy from that context into the image, you're going to get a lot of stuff in your image that you may not want there. You could have secrets in there. You could have infrastructure information in there that you do not want included in the container. You could have, unit test stuff that just ends up leaving you with a large container that just has too much stuff in it. We already discussed, shrinking your attack space so that there's just less opportunity for hackers to get in and mess stuff up for you. So yeah, when I see a Docker file where the entire source tree is being copied over in one line, that's a problem. Also, when you do that, that's one layer. Each command is a layer. That's what it results in. So any code change at all is going to result in having to regenerate that layer. That's just a waste of time, really. So it's good to organize your Docker files to have the least often updated stuff closer to the top of the file. Another thing that is interesting, you could include your Git directory. I didn't even think about this, and I'm pretty sure there are containers running out there that include Git directory information. The Docker ignore file looks much like the git ignore file. The format is pretty much the same. You shouldn't have to get too fancy about filtering or whatever. If you do, you might want to think about reorganizing your code base, but it's pretty simple to use. Just make sure you're actually using it. All right, one other thing, if you're pulling, for example, your Java source or any other source into the Docker file, you might also be including the build tool like Maven or NPM as well. Learn to use Docker's multi-stage Docker builds so that you don't end up with all of that extra stuff in your production image. That problem is not limited to Java projects. That's anything. Any of those package managers or build tools, you don't need those in your production image. All right, I'm glad you guys are loving these bananas. I really enjoyed putting this together. All right, so now we have finally come down to distroless containers, images, containers. What are they? Basically, the idea is to not have all of the extra fluffy stuff that you don't need. The idea is to only include what you absolutely need for your application. This reduces your attack vector so that you have less opportunity for problems or vulnerabilities to arise. You don't need the cherry on top. So one thing to recognize too, I'm going to mention again that Docker Hub has official images. These are a curated set of Docker repositories that are based on Docker Hub. Just because they have that, official label doesn't mean that they are the best choice for you to use, especially if you're concerned for size or for limiting your risk. So pulling in those large parent or base images that have a bunch of stuff you don't need just increases your risk. It increases your attack surface area. And also, just in a general, just everyday working, shipping those large images around and storing them can become pretty clumsy, slow, and expensive. One of the biggest things we already discussed, not including package managers, that was in the context of your code, but what about package managers like apt-get, those kinds of things that usually come along with an OS? You don't need those either. So that's one thing that distroless containers try to give you. The images that those containers are based on don't contain a shell even. Certainly not package managers, but also not a shell. Now that's an interesting fact because I was in a situation where, and this is horrible, don't judge me, but I was in a situation where there was some issue with production containers that were running, and one of the ideas was to exec into those containers and figure out what was going on. You shouldn't be doing that. You don't need a shell in your production container. If you find that you do need a shell, there are other things that you need to put in place to avoid that kind of troubleshooting in production. That is meant for debug purposes, things like that. You certainly shouldn't be doing that in production. So don't feel sorry to see the shell go when we talk about distroless containers. All right, so how do you actually build these things? I have a link here. There are Google distroless containers. I'm just going to post that link in the chat so that you can pull it up and take a look at it. All right, Google has several containers that have been hardened for production, and they do not contain shells. They just contain the bare minimum of what you need for certain development environments or certain, code environments. Here's an example of one, being built for Java. This is an example of a multi-stage build as well. So that first section, beginning with from, is actually pulling an image from Docker Hub, the slim JDK11 image, and the important part is, that as build environment part that indicates that we're going to reference everything that happened in this section later. We go ahead and build a simple application, create a jar file out of it, And then the second part actually pulls in one of the Distroless containers that are available from Google. And we just copy the result of our build into that. And then we specify the jar file that we want as our command. The entry point is for this particular Distroless images is java-jar. So we just need to provide the command of the jar file that we want to run. So pretty cool, pretty simple. Definitely use multi-base images if you're not, or multi-stage builds if you're not doing that already. Pretty important. All right, now we are not ones to just believe everything we're told. So I'm going to pull up my terminal here in a moment. And I want to show you the difference between a couple of the JDK images that I've pulled from Docker Hub compared to that Distroless image. All right, you should be able to see my terminal now. Just make sure. Okay, so I've cleaned up my system so you don't have a lot to look through. But I'm just going to pull up the images that I have right now that are existing on my system. And ignore the ones right now that start with MM11. I'll explain what those are in a second. But what we care about are the images that came directly from Docker Hub. So we've got this OpenJDK tagged 11 JDK Slim. And look at the size of this, 429 megs. Okay. Now let's look at the one that's not Slim, 659 megs. Okay. And then check out the Distroless from Google, 206. So you can see there really is a difference in the size. Now, that's good, but I want to know if that really benefits me at all. I mean, obviously not having a huge image that I have to ship around, that's great, but does this benefit me in any other way? And yeah, I noticed that too. This created date 51 years ago. I thought that was pretty interesting too. That's something I want to look at later, but yeah. So anyway, I want to pull up images that I have pushed into my personal Jfrog platform so that I can show you the number of vulnerabilities that are in each of these images. All right, so I've got the packages here. I've pushed my Docker packages up here. There's two for OpenJDK. I've got the Slim version and the 11, the regular version. So let's start with that one and just see how many vulnerabilities we have. I'm not going to go deep into what they are. I just want to see the number just for, you know, a good metric. Okay, so here we have 67. So remember 67. All right. I'm going to go back to the Slim version and see how many are in there. Okay, I have 36. That's pretty good. All right. Now let's go into the Distroless one and see what this one looks like. I see 51 here. So did we really improve anything? Does that built 51 years ago mean anything? These are things, you know, like I said, don't just believe everything you hear. You still need to pay attention to what packages are actually being included in your base images. One thing that can trip people up is, especially when you're on an internal project, you may not even have the, you know, because of the hierarchy of base images, the base images that you're using might have its own base image. You've got to go all the way up to that layer 1 and check out and see what everything is being used in your build. All right, so definitely check out those Distroless images, compare them to other images that you are using today and see if they are beneficial to you. Lastly, I did write this DZone article. I'm going to share that link with you as well. That just gives you some more information about choosing a Docker registry, or any registry for that matter, whether it supports OCI or Docker or both. It's meant to just give you an education on where your images are being stored. Now that you have them built, where do you put them to make sure that they are protected and that they don't, you don't get something unexpected. And then also, if you're interested in, of course, just playing around with the vulnerability checking and pushing those images up to the Jfrog platform, there's a link here to use to get one set up. It's really fast, really easy to use. I'll put that link here as well if you want to do your own experimentation. All right, and that is all I have for you. Don't forget to go fill out the survey to get your chance to win a shirt.
Yeah, thank you, Melissa. We have a few questions here.
Yes.
I'll start with the biggest concern.
Okay.
It's about getting rid of the shell. So for developers, it's a big barrier for adoption. They feel like it will be impossible to investigate word issues and things like that. What would you answer a developer about that?
Well, I mean, depending on what you're using, like I said, you should never be going into a production image to do troubleshooting of that sort. You can use logging. You can, send all of that logging out into some other system in order to check things that way. And also in your development environment, though, you have the opportunity to, you don't have to use, in fact, you probably wouldn't want to use a distroless image with your development, because you do need to be able to get in there and check things out. So this is, I would reserve distroless images for production. You want that same image that ends up in production to go through your testing, though, thoroughly. So, because you want to be able to just promote the same image. You don't want to have all of your testing done on the development image and then turn and use a distroless image, because there could be things missing there that you don't realize. So you definitely want all of your testing and stuff to be done on the distroless image as well. But yeah, for development purposes, I wouldn't use a distroless image.
I will check out the project Pixie and CNCF as well, which is helping you to instrument, get all of this observability and tracing and debugging out of the log.
Yes.
Quickly, about the Java 7 version, which is not container aware, what do you mean about that?
So what I mean by not being container aware is when you try to set limits, like on CPU usage, it will actually use the resources that are on the host, not in the C group for that container. So not a huge issue if you only have one container running on the system. But if you have other things running on the system, you might find yourself starving the container or starving other processes that are running on the host.
Melissa, can I share my screen at the same time while we're answering the question? We wanted people to fill out the survey. Thank you.
Well, there is another question from Jamil Noor. It's getting very technical, so maybe Jamil, if you're on Slack, maybe we could answer you offline about this one.
Yeah.
There was a quick question, Melissa, about your usage of pre-Docker containers. How and where was that?
My usage of what? I'm sorry.
The question is from Thomas. I might have missed it, but
pre-Docker containers
that you were using pre-Docker containers?
Like Linux containers,
so
or Solaris containers, those types. So yeah, Docker's made containers famous, but containers existed long before Docker, for sure. Docker has a bunch, it's a whole suite of capabilities, right? It has the ability to build to deliver, you publish to Docker Hub and stuff like that, share with other people. It has the ability to launch and run containers. All of that was put together in a single tool that developers can use that made it really easy for them. But not to say that containers didn't exist before Docker did.
And there was some tooling around that before Docker to bootstrap an LXA setup, namespaces, and everything. Yeah. Okay. Well, maybe we have another more technical question. So maybe I'll reach out to you, and we'll share that with the rest of the folks later
Absolutely.
on. We're way over time. RG.
Thank you, Melissa. It was really nice to meeting you virtually, and we're hoping that you'll have a chance to come to Canada once we're going to be back in person. We're probably going to do a survey soon just to asking if our users are ready for in person, and we're going to be probably start looking for events and venues to starting to organize, because we also missed it a lot. All right. So just before we're going to close out, we have to, not have to, but like you can do a post-event survey and have a chance to win a prize. Thanks to Jfrog, who is donating today a Raspberry Pi 4 desktop kit and also titanium USB key that helps to secure your supply security chain. So I have right now 31 respondents. I will probably make a last call, just 32, just a few more seconds. 33. Okay, so people are filling up still. That's good. Julia, you want to add anything before we gonna go for the draw?
No, I think I'm good. I just wanted to give a shout out to Melissa again. Thank you so much for, as I mentioned in the chat, making this really fun with bananas and monkeys. You can't go wrong. So thank you for that. And for those of you who are interested in chatting about Burnout again, it's Thursday in the CNCF Slack workspace in the Burnout channel. Join us there. And I think we're ready to announce the prizes. I'm actually just going to stop the recording now.
Perfect.
Bye.
So I have 36, 37. Okay.